Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session we are discussing current density. We will see what are circular mills, what are square mills, what is centimeter square in inches, in centimeters, then what are square mills and what is circular mills, how we can convert one unit into the other. If we have 500 circular mills ampere current density, how we can convert into metric scale. Here is 500 circular mills per ampere and how it becomes around 400 ampere per centimeter square. If you are new to my channel, you can subscribe it and you can press bell icon, notification for all, and you will notified on my every new video. After watching this video, please give your opinion how you find this video. Let's start. When we say current density, these are two words. Current density in a transformer. I received a comment from my viewer. He watched my video number 430, how to calculate Farad core maximum power handling. My viewer is asking, in what video is the current density handled in detail? So I don't have this video before. Now we will discuss in detail. So the units 500 or 700 mils per ampere is the RMS current or peak current. Thanks for this very informative video. Thank you. We know when we apply voltage to any conductor, either as a resistor, any conductive material, we apply voltage here, current flows in this material. What is the current? At any point of this inductor, then 6.25 10 raised to power 18 electrons will pass from this point in 1 second. This is condition. Number of electrons in 1 second. These two conditions will meet. The amount of current is 1 ampere. Any point here, there. But when we say transformer, it have Farad core, it have bobbin, it have winding, it have insulation, there is laminated wire, there are gaps between the wires, there are strands, so many parameters are involved here. Core is in this shape, winding in this shape, but in this window area, in this area, how much amount of copper is there? What is the copper area? When we say area, because it have length, width, all the copper wires will be considered as a one block of wire. Length, width. When we say length and width, it will considered as area. Second word, density. Density is combination of two different things. What is the population in a specified area? What is the amount of any material in one volume? When we share relation between two things, that is density. For example, in our routine life, we see news on TV. They are discussing that there was very heavy crowd. There was 100,000 people. They get idea from 1 meter by 1 meter. One meter. How many people are there in this 1 meter? Then they take another idea, different places, then they take average. For example, here is one person and here is one person, 2 persons per square meter. 4 person per square meter. 5% per square meter, 9% per square meter, like this. When we show a number in any dimension, it is called density. If there are too many people here, it will be called that it is highly populated area. If we know the population of any area, we say in 1 kilometer, how many people are living there? That is density, population density. Same here. We know the current, but now we are conditioning it with the copper area. When we convert this winding, this area into window fill factor, that time we determine the copper area of this transformer. Then we will know how much current will flow in that copper area. When we take dimensions, one measurement system is inches, the second centimeter. If we say 1 inch, it is 1 square inch. Same area, if we express in centimeter, it is 2.54 centimeter, 2.54 centimeter. Same, 1 inch is equal to this centimeter by this centimeter, so it will become centimeter square. Multiply this, multiply with this, the total area will be discovered. Here 1 multiplied by 1, it is 1 square inch. If we break down it into subunit, so 1 centimeter is 10 millimeter. But if we break down inches, 1 inch is equal to 1 over 1000. It is called 1 mil or 1 thou, and it is 0.001 inch. 1 thou. That means if we divide this point up to here, it will become 1000 pieces, and from here to here it will become 1000 subparts. And here 2.54 centimeter, it will become 25.4 millimeter. 25.4 millimeter. When we see the wire area chart, we see copper bare area, that is without insulation, that is always shown in thous, mils. So it is 1000 by 1000 mils square, because when we say square, that means length, width. This 1 thou or 1 mil length and width, we will bring it here. This one portion 0.001 inch by 0.001 inch, 1 thou by 1 thou, or 1 mil by 1 mil, it is 1 square mil. When we say AWG wire chart for winding, that shows data in circular mills. Circular mills, that if this wire, it have outer diameter from here to here 1 thou, 1 mil, or from here to here, from here to here, in any direction, because wire is round. If its outer dia is 0.001, so that means it is 1 circular mil, because it is in circular shape. CM, circular mil. This is square mil, and this one is circular mill. If you see here, from here to here, here to here, any direction, this circular mill will remain same. But if we see this one, this boundary is 1 mil, and this boundary is 1 thou. So area is different. It have more area than this one. Here length, width, but here pi r square. So there are conversions in these circular mills, square mills. Now we have circular mills, square mills, then we have centimeter square. If we have circular mills and we want to convert into square mills, circular mills to square mills, its radius 0.001 divided by 2, 0.0005. Point 0.005 square. It is 7.857, 10 raised to power minus 7. 0.7857, 10 raised to power minus 6. So mills same. If we multiply circular mills with this number, it will become square mills. And if we have square mills, we want to convert it into circular mills. 1 divided by 0.7857, it will become 1.2727. 1.2727. It is in calculation, but normally it is considered as 0.7854 and it is considered as 1.273. We can use this number or we can use this number, the same. Now we will see centimeter squares. It is 2.54 centimeter, that is equal to 1 inch. And if we will divide this area, here is 1 centimeter, 2 centimeter and 0.54. One centimeter square, 1 centimeter, because 1 centimeter here, 1 centimeter here, 1 by 1. And now this one is 1 and 0.54, 1.54, and here 1.54, 1.54, 0.54 by 0.54. So this is area of this equivalent 1 inch area. Now when we see wire data sheet for magnetic design, it is recommended that 500 circular mills per ampere current is recommended. Here we have square mills, 1000 in this area, 1000 in this area, that are square mills. When we want to check circular mills, at that time we can multiply with this one to determine square mills. 500 multiplied by this 0.7854, we can determine the number of square mills. 500 circular mills are allocated for 1 ampere. 500 circular mills, we can say this is the area of this wire in any one direction. 500 here, 500 here, like that, in any one area, either it is in length, width, circular shape, square shape. 500 circular mills, that thickness of wire is allocated for 1 ampere. Or we can say For 1 ampere current, we need 500 circular mils thick wire. Now wire is recommended in this number. When we are discussing core, its measurements are in centimeter, millimeter. We need to convert this into centimeter to match our calculation with this one, or we can convert back centimeters into inches to follow calculation method. Which type of calculation method you are using, that will depend up to you. Circular mils per ampere, if we want to convert it into centimeter square, what we will do, circular mils to centimeter square, we will multiply with 5.06 10 raised to power minus 6, or square mils to centimeter square, we will multiply by 6.45 10 raised to power minus 6. If we have any area, wire area in circular mils, we will multiply this number with this to determine equivalent centimeter area. Now we say we need 500 circular mils in inches. How much area will in centimeter? Because here we are counting circular mils. How much area in metric scale? When we say area, that is length multiplied by width. 500 multiplied with 5.066 10 raised to power minus 6. It is 0.002533. 500 circular mils equal to 0.002533 centimeter square. Now this is 1 centimeter by 1 centimeter. We can say this small area is allocated for 1 ampere current, because we are changing the dimension. Amount of current is same. This bare area of the copper wire is required for 1 ampere. Here we will say this area is required for 1 ampere. How much current will flow in this 1 centimeter by 1 centimeter copper area? We can divide simply 1 divided by 0.002533. It will become around, in 1 centimeter square, how much current will there? 394.788 ampere. Why? Because we allocated this area in 1 ampere, and now we divided 1 over, that is 1 centimeter square, this wire area and this wire area, length and width, divide with 0.002533. It will become 394, and normally it is called 400 ampere per centimeter square. This smaller area is allocated for 1 ampere, and in this area 1 centimeter square, 1 centimeter length, 1 centimeter width, it can handle up to 400 ampere in this transformer. If this value remains between 400 to 500 ampere per centimeter square, that means that transformer will work normally. If this current value will increase up to 700, 750. At that time, that is aggressive condition. If this 1 centimeter is handling this current, it will work safely. Copper will not heat up. Copper will not dissipate power. There will low copper losses. But when we will increase the current, it will become heat up. So when we are calculating, when we are using proper area product, which type of topology we are using, what is frequency, what is Bmax, either we are using in Tesla or either we are using in gauzes. They're just only, if we are changing in gauzes, then we need to change formula for gauzes. When we are selecting proper frequency, proper Bmax, proper area product, we are selecting proper switching topology. At that time, if the current value in calculation becomes this one, that means that transformer will work normally. If it is coming less than this, 200 ampere per centimeter square, at that time we are not using the copper properly. We are including the cost of the material and we are not taking benefit from that material. If we are moving in this zone, 700 to 750 ampere per centimeter square, that is wrong. At that time we need to adjust our switching frequency, we need to change our Bmax, we need to select proper wire gauge, proper wire area, so that the window fill factor will become within range. I hope this video is informative. If it is good, hit the like button. If you have any question, please write in the comments. Thanks for watching.